When you hear numbers like millions of feet or nanometers, what does that actually mean to you? For most of us, they're just kind of abstract noise, right? But what if there was a way to actually feel those numbers, to turn all these confusing units into a simple, powerful mental tool? Well, let's dive into how a little mental trick could have saved NASA a whole lot of money.
And believe me, this isn't just some hypothetical thought experiment. This is real. Back in 1999, NASA launched the Mars Climate Orbiter. We're talking about a $125 million mission. But instead of orbiting Mars, it just burned up in the atmosphere. And the reason for this total disaster wasn't some complex rocket engine failure. Nope, it was a stupidly simple miscommunication. One team was doing their math in feet and pounds, and the other team was using meters and kilograms. Whoops.
So you have to ask, how on earth does a simple unit mix-up cause a multi-million-dollar spacecraft to crash and burn? It really points to a much deeper problem, one that we all have. Our brains are just not naturally good at comparing different scales and sizes. So the real question is, how do we fix our own intuition? How do we prevent these kinds of mistakes?
Okay, so here's our game plan for today. We're going to start with that crazy NASA story. Then we'll learn this new technique called thinking in magnitudes. I'll walk you through the mental code, show you how easy it is with the metric system, and then we'll even use it to tame the wild imperial system. And by the end, you're going to have a new measurement superpower, I promise.
All right, let's get right to the solution. It's a concept called thinking in magnitudes, and it's basically our secret weapon against the kind of confusion that doomed that Mars mission. It's all about making numbers feel intuitive.
So, what is this magnitude notation thing really? Well, at its heart, it's just a system for converting any number with any unit into one single standardized value. This means you can compare something tiny like nanometers to something huge like miles almost instantly, and all in your head, no calculator needed. It creates a common language for numbers, which is exactly what those NASA engineers were missing.
And here is the absolute best part. You do not need to be a math genius for this. Seriously, this is more like a mental conversion code that you can do entirely in your head. All we have to do is learn a few super simple rules. Let's get into it.
Okay, let's look at the basic building blocks of our new code. Think of it like we're just translating regular numbers to a new scale. On this magnitude scale, our starting point, the number 1, is just 0. Easy enough, right? From there, you only have to lock in a couple of key values. The magnitude of 2 is about 0.3, and the magnitude of 3 is about 0.5. And since we use a base 10 number system, the magnitude of 10 is exactly 1. That's it. With just these, we can build everything else.
And now for the magic trick. This is the single most important rule of the entire system. Multiplication just becomes simple addition. So to find the magnitude of, say, 4, you just think to yourself, well, 4 is just 2 times 2. So instead of multiplying, we just add the magnitude of 2 to itself. 0.3 plus 0.3 equals 0.6. It is literally that easy.
And once you get that one little rule down, you can build out this entire single-digit code in seconds. Need the magnitude of 6? Well, that's just 2 times 3. So you add their magnitudes. 0.3 plus 0.5 gets you 0.8. What about 8? That's 2 times 4, so you add 0.3 and 0.6 to get 0.9. And just like that, you have the mental toolkit to find the magnitude of any single-digit number.
So we have the code for the numbers. Now let's apply it to some actual units. And we'll start with a nice, clean, logical one, the SI system, or, the metric system. Because this whole system is built on powers of 10, you're about to see just how beautifully our magnitude tool works with it.
Let's run through an example. How far is 67.4 nanometers? Sounds really complicated, right? But watch. First, the number, 67.4. Let's just think of that as 6.7 times 10. The magnitude of 10 is just 1. And 6.7, well, it's between 6 and 8, so its magnitude is somewhere around 0.8. Add those together, 1 plus 0.8 gives us a magnitude of 1.8 for the number. Now the unit. The prefix nano is just science talk for 10 to the power of -9, so its magnitude is literally just -9. And the last step, you guessed it, add them up. 1.8 plus -9 equals -7.2. That's it. That's our answer, in meters.
All right, you've handled the metric system. No problem. You're ready. It's time to face the final boss, the awful, chaotic, totally arbitrary, but somehow still hanging on, imperial system. It might seem like a mess, but our little magnitude tool is powerful enough to tame even this beast. And I mean, just look at why it's such a challenge. The SI system is elegant, right? It's all logical, based on tens. The imperial system is, well, it's a disaster. It's just a total mess of random numbers. You got 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile. It's like it was designed to be confusing.
So, to beat this final boss, we just need a few little cheat codes. We just need to memorize the magnitudes of its basic units compared to meters. You only really need to know 3. An inch is about -1.6, a foot is -0.5, and a mile is 3.2. Got 'em? Good. Let's put them to the test.
Let's try a big one. How far is 7,500 miles? Okay, first step is to break it down in our heads. That's 7.5 times 1,000 times 1 mile. Now we find the magnitude of each piece. For 7.5, it's between 6 and 8, so its magnitude is roughly 0.9. 1,000 is just 10 cubed, so its magnitude is exactly 3. And from our new cheat codes, we know a mile is 3.2. Now for the easy part, just add them all up. 0.9 plus 3 plus 3.2 equals 7.1. And just like that, we mentally converted 7,500 miles to our standard magnitude scale.
So look, what you've just learned isn't just some clever party trick. This is a fundamental upgrade to how your brain perceives the physical world. You've essentially just given yourself a new superpower: measurement intuition.
There's actually a word for this. It's called becoming measurate. Just like being literate means you can read and being numerate means you can work with numbers, well, being measurate means you can intuitively understand and compare physical things. It's a genuine life skill for making sense of the world around you.
All right, now it is your turn to use this new power. You have the mental code. You know the rules. So here's your challenge. Calculate the magnitude of the number of seconds in a year. Don't grab a calculator. Just break it down in your head. Days, hours, minutes, seconds. Find their magnitudes and just add them up. You might be totally shocked at how close you can get. Go on, give it a try.